and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 3, Lesson number 5 on dividing whole numbers with decimal remainders. Now, sometimes when you divide two whole numbers, you get a whole number. 24 divided by 3 is 8, right? On the other hand, many times when you divide whole numbers, like let's say 23 divided by 5, right, you get something like 4 with a remainder of 3. Which then, if you write it as a mixed number, it might be 4 3/5. All right, but that 4 3/5 can also be written as 4 along with some decimals, and that's what we want to look at today. How do you divide two whole numbers that then have decimal remainders, and how do you figure out what that decimal remainder is? We're going to then come up with what's known as the standard algorithm, and it's going to be pretty much easy as long as you can do long division, which I realize is not anyone's favorite, certainly not my own. But let's jump right into it and see if we can start to understand how that standard algorithm works. All right, here we go. Understanding the standard algorithm, exercise number 1. Consider the problem 17 divided by 5. The diagram shows 17 cubes to help visualize this problem. Letter A asks us, if each of these 17 cubes was broken into tenths, how many tenths would there be? Fill in the blank below. So let's talk about this a little bit, right? I want you to think about each one of these cubes as being the number 1, right? But of course, we could take one of these cubes and we could slice it up into 10 equal parts, giving us, right, 10 tenths in one of these things. The question is, if I have 17 of them, 17 wholes, how many tenths does that represent? Take a minute to just think about this. Well, since there are 10 tenths in one whole, right, we can simply multiply 17 by 10, and that tells us, right, that there are 170 tenths sitting over here. Now, I'm not going to try to draw that because that would literally take up the rest of our time. But I want you to keep in mind that 17 wholes and 170 tenths are exactly the same thing. Now let's take a look at letter B. Divide the number of tenths you found in A by 5 instead using long division. All right, so keep in mind we're trying to figure out what 17 divided by 5 is. But since 17 wholes is equal to 170 tenths, we can also divide 5 into 170. Literally, we'll just put 170 right there, maybe extend my fraction bar just a bit, and figure out what that division is. Pause the video for a moment now, take a few seconds, and figure out that quotient. Well, we all know how to do long division like this, so let me just bring the screen up a little bit and let's do it. 5 goes into 17 3 times, right? That gives us 15. We subtract. Of course, we subtract and get 2. We drop the 0 down and get 20. 5 goes into 24 times. And we subtract, and we get a remainder of 0. So we have an answer of 34. Right? But keep in mind that what that really is 34 tenths, right? It's not 34, it's 34 tenths. So let's take a look at letter C, right? Based on what you found in B, fill in the following and express your answer as a decimal, right? So keep in mind that 17 divided by 5, right, is 34 tenths. That's what we found. 17 divided by 17 divided by 5 gave me 34, but specifically 34 tenths. Now, what is 34 tenths? Well, now we can kind of simplify this, right? 34 tenths, 10 would go into 34 3 times, right? And that would give us 30. And then we'd have 4 left over. So that would be 3 and 4 tenths. But that, of course, is the same as 3.4. Okay? So this leads us to the standard algorithm. And it's really, really simple, right? Now remember, up above we had 5 divided into 170. Here we have something that looks like 5 divided into 17.0. So our standard algorithm is to simply do the division the way that we always would. We would say, all right, 5 goes into 17 3 times, giving me 15, right? I'm going to do the subtraction just like I did above. Just like above, we had 17 minus 15, and we got 2. Just like above, I'm going to drop that 0 down. But the big difference is wherever that decimal place is, I'm just going to leave it there, right? So that decimal place is right there. Maybe make it a little bit darker so that it'll show up on the screen a bit more. And now I say, how many times does 5 go into 20? That's 4 times. Subtract, and we've got 0. So 17 divided by 5 is 3.4. We could easily check this now by taking 3.4, multiplying it by 5, and we would get 17. So it's a piece of cake to divide two whole numbers that might involve a decimal at the end. We just have to keep track of where that decimal is and extend with as many zeros as we need in order to get a remainder eventually of 0. All right, let's get a little bit of work on that in the next exercise. All right, getting some practice dividing. Exercise number 2. Find each of the following quotients in decimal form. All right, now let's talk about this just for a minute before we start to launch in and get some practice. What we really have here is 26 divided by 4. What we have here is 58 divided by 8, and here we have 23 divided by 5. Don't be thrown off by the 0.0, right? 26 and 26.0 are the same thing. In fact, I could have had 26.000000, 58.000000, etc. We can have as many zeros after the decimal point as we want and as many as we need. So let's do letter A together. All right, let's do it. So we're going to say, well, 4 goes into 26 how many times? Well, it's going to go in 6 times, right? And when I do 6 times 4, we're going to get 24. And when I subtract, I'm going to get 2. And I'll drop that 0 down to get 20. I'm going to bring that decimal point right up there. 4 goes into 25 times. 5 times 4 is 20. Subtract, and I get 0. So 26 divided by 4 is 6.5. No big whoop, right? Very, very easy. We do exactly what we're doing with long division. We just keep track of where that decimal place is and add as many zeros as we need to. Let's do letter B together. It's really important that we do some of these together before we have you do one on your own. 58 divided by 8. All right, 8 goes into 58 7 times, right? 7 times 8 is 56. We're going to subtract. We'll get 2. We drop the 0. And we get 20. 8 goes into 20, not an even number of times, right? So in fact, we're going to get 2 there, 16, subtract, and we get 4. Now for a moment, let's kind of break out and talk about this a little bit. Before, every time I kind of did that second step, I had a remainder of 0 and I was sort of done. Here though, I have a 4. So what do? Well, all I'm going to do is put another 0 onto that 58.0. I'm going to drop that down to give me 40, and now 8 goes into 40 5 times. Subtract, and I have a remainder of 0. So 58 divided by 8 is 7.25. Why don't you try one on your own and do 23 divided by 5? All right, this one's pretty easy too. So let's do it together. 5 goes into 23 4 times. That's going to give me 20. I'm going to subtract. I'm going to get 3. Put the decimal point down. Drop the 0. I have 30. 5 goes into 30 6 times. 6 times 5 is 30. Subtract, and I get 0. So 23 divided by 5 is 4.6. These are relatively easy decimal division problems. We're going to get into some more challenging ones in a bit, but that's the entire method, right? We divide like we always do. We just have to make sure to keep the decimal point sort of where it is located each time. Keep adding on as many zeros as you need to keep doing the division. Let's keep going and look at an interesting thing that happens when you divide two whole numbers. So sometimes when you divide two whole numbers, an almost magical thing happens, which is instead of eventually getting a remainder of 0, a pattern develops to tell you that you'll never get a remainder of 0, and the decimals start to repeat themselves. All right, we're going to show how you then how you show that repetition of decimals in just a minute. So let's take a look at our first example, which is 8.0, or just the number 8, divided by 3. Let's go through this one and see kind of how it works. All right, so 3 goes into 8 2 times, right? And of course, 2 times 3 is 6. And when I subtract, I get 2. I drop that 0 down, and I have 20. Now I'm going to have my point right now. Now I'm going to say, well, how many times does 3 go into 20? That's 6 times. 6 times 3 is 18, and 20 minus 18 is 2, right? Still no remainder of 0, so maybe I would drop another 0 down. And then how many times does 3 go into 20? Well, 6 times. 6 times 3 is 18. I would subtract, and I'd get 2, and still not a remainder of 0, so then I'd drop another 0 down. But as you can probably tell, right, I just keep getting 20, right? And I keep subtracting, etc., right? And this process is just going to happen again and again and again and again. Every time I'm going to get 2.666666666, right? So the 6 ends up getting repeated at the end of this decimal. I can show that because obviously I can't write out all the 6s. I'd be doing it forever. Literally, there are an infinite number of 6s. I can show it with what's called a repeated decimal bar. It actually has a name. It's called a vinculum, or a vinculum. It's a very difficult word to pronounce, and one you absolutely positively do not need to know. But it's kind of a neat, a neat little piece of terminology. So what I'm going to do is I'm going to say my answer here is 2.6 with a repeated decimal bar. So when you divide two whole numbers and they end up having sort of like decimals in them, one of two things happen. Either you continue doing it and the decimal terminates, and you know it'll terminate because you'll get a remainder of 0 and there'll be nothing left to do. Or eventually you'll get a repeated pattern, and once you see that pattern repeated, you can stop and then put a little horizontal line over the portion of the pattern that's repeating. And that's very important. Only put it over the portion of the pattern that's repeating. So what I'd like you to do now is I'd like you to pause the video, try this one and try this one. One of them's going to terminate. One of them's going to repeat forever. Okay? So watch for that and see what happens. Try both of those. All right, let's do 55 divided by 8. Let's take a look. Move my little guy over here. All right, 8 goes into 55, not 7, 6 times. Oh yeah, 6 times, right? Almost thought 7, but that would give me 56. So now I'm gonna have to subtract. And of course, 55 minus 48 is going to be 7. All right, have my little decimal. I'm gonna drop the 0. That's gonna give me 70. All right, that's going to be 8. 8 times 8 is 64. All right, I'm going to subtract, get a 6. It almost seems like we might end up getting a repetition here, so I'm going to bring down a 0. Then I'm going to have, whoops, sorry, I'm just trying to extend that division bar a little bit, and it turned out to be quite messy. All right, now I'm going to have 7. 7 times 8 is 56. I'm going to subtract, and I'm going to get 4. I'm going to drop that 0 down. And 8 goes into 45 times. That gives me a 40. I'm going to subtract, oh, and I have a remainder of 0. So no repetition there. 55 divided by 8 is 6.875. A little bit, again, difficult to see the decimal point, so we'll make it a little bit bigger there. 6.875. Now what I'm hoping is that on this one, you saw some repetition. Let's go through 35 divided by 6. Here we go. 6 goes into 35 5 times, right? 5 times 6 is 30. We subtract and we get a 5 as our remainder. We drop our 0 down and we get 50. All right. 6 times 8 will give me 48, which when I subtract will give me 2. Again, tack on another 0, drop it down, and I'll get 20. 6 goes into 20 3 times. That'll give me 18. Subtract, I get 2. And let me just break out for a minute to talk about this. Notice when I did 50 to minus 48, I got 2. And then I got 20 minus 18, and I got 2. Anytime you see that happening, the pattern is starting to repeat itself. But if you're not sure, just keep going. So in other words, right, I can tack on another 0, drop that 0 all the way down. 6 goes into 23 times. That gives me 18. Subtract, I get 2, tack on another 0, drop it down, 20, 3, etc. Now, we got to be careful. How do we write this? Well, let's be very clear. We have 5.833333. The portion that's repeating does not include the 8, nor does it include the 5. It only includes the 3s. So the way I would write this now as a final answer is 5.83, and then I will only put a bar above the 3, not above the 8 as well. In fact, if I put the bar above the 8 and the 3, then that implies it should be 5.83838383838383, which it's not. By the way, that can happen. You can certainly have kind of a 2-digit repeating pattern, all right? It doesn't have to be a 1-digit repeating pattern, but it isn't that way in this case. All right, let's keep going. An applied problem with buckets. I gotta love buckets. Anyway, exercise number 4. Jason pours 28 gallons of water into 6 buckets that each hold the same amount. How many gallons does each bucket contain? Round your answer to the nearest tenth of a gallon. Justify your answer. All right, let's talk a little bit about this problem. This is like the definition of division, right? Division, right, when we have a total quantity and we literally have buckets or things that we're putting that quantity into, and we want the same amount in each one of them, right? Then we are looking at 28 divided by 6. Simple as that, right? We want to figure out this answer. All right, so what I'd like you to do now is I'd like you to take a moment and try to figure out what the answer to this division problem is. Hint, it's gonna have a repeated decimal in it. And then once you have that repeated decimal, see if you can use it to figure out how to round this answer to the nearest tenth. Take a little bit of time to do this. All right, now one thing that's very important, in all the problems that we've done so far, I've kind of set them up for you. Here's the division, you go ahead and do it. It's really important that if you've got something like 28 divided by 6, that you realize that you have permission to put a decimal point and then as many zeros as you need to afterwards. All right, so you could start with 28.0, 28.00, etc. It wouldn't matter. Let's go through this. 6 goes into 28. How many times? Well, it's going to go in 4 times, right? And that's going to give us 24. And we're going to subtract 28 minus 4. 28 minus 24 is 4. Then we're going to drop a 0 down, and we're going to put that decimal point there. 6 goes into 46 times. That's going to give me 36. I'm going to subtract. 40 minus 36 is 4. Oh, look at that. I'm going to drop a 0 down. 6 goes into 40 6 times. 6 times 6 is 36. Subtract, we're going to get 4. Drop the 0 down. Hopefully by now you get it, right? It's just going to be this pattern. So if we didn't want our answer rounded, it would be 4.6 with that repeated bar. But it tells us that we want to round to the nearest tenth of a gallon. That's this decimal place here, right? So in order to round that, of course, I'll look at the next one over, which is also a 6. Because that 6 is 5 or greater, it means I should round that up to a 7. And so my final answer should be 4.7 gallons. 4.7 gallons in each one of these buckets. All right, let's look at one more kind of cool thing that you can do with division of whole numbers that involve decimals. Converting a fraction into a decimal. Now, fractions and decimals can be amazingly frustrating for students, all right? Never forget that both fractions and decimals are numbers. 1/2 is as much of a number as 5 is. You know, 0.072 is as much of a number as 8 is, right? They are numbers, okay? The other thing that you have to keep in mind is that every fraction represents a division problem of the numerator divided by the denominator, every single one of them. And because we now know how to divide two whole numbers in terms that give us decimals, we can now take a fraction, convert it to a division problem, and then convert that division problem into a decimal, which means we can take a fraction and convert it into its decimal form. All right, it's really, really cool. So let's take a look at how this is done in exercise number 5 by bringing this way up here. Let's take a look. Convert each of the following fractions into an equivalent decimal by using long division. If the decimal begins to repeat itself, use the repeating decimal bar to show that. Show your work. All right, simple as that. Let's take a look at 1/4, right? Now, how do we turn this into a decimal? Well, it's simple enough, but we have to start by recognizing that 1/4 is equivalent to the number 1 divided by 4. And I get the fact that you're not used to taking a smaller number and dividing it by a bigger number. But that's the way it is when the numerator is smaller than the denominator. So how should I write this? Well, I'm going to write it as 1 divided by 4. And I'm going to add a few zeros after the decimal point just so I can do that long division. So here we go, right? So I can't put a 4 into a 1 at all, so I'm going to put a 0 there. All right, maybe I'll even put 0 here and then drop that first 0 so I have a 10. Then 4 goes into 10 2 times. 2 times 4 is 8. Subtract, and I'll drop the next 0 down. 4 goes into 20 5 times. 5 times 4 is 20. I'll subtract and I'll get 0. So that's it. 1/4 and 0.25 are the same quantity. And you may have already seen that in the past, right? It also kind of makes sense. If you think about what a quarter is, like if I said, hey, I've got a quarter, how many pennies is it? You'd say 25. It's 25 cents, right? It's 0.0 or 0.25 is 1/4. All right, let's now convert 1/3, 3/8, and 2/5 also into decimals. I'd like you to take a few minutes and see if you can do some of those on your own. All right, well, of all the remaining 3, the only one that ends up having a repeated decimal in it is 1/3, and it's one of the most, standard repeating decimals that you'll ever see. But let's first do it, right? Just like before, 1/3 is equivalent to 1 divided by 3, right? So that's going to be 3 going into 1, and again, I'll get prepared by doing some zeros afterwards. 3 goes into 1 0 times. You don't really have to do that particular line if you don't want to, but it's kind of nice. 3 goes into 10 3 times. That's going to be a 9. I'm going to subtract. 10 minus 9 is 1. I'm going to drop the next 0 down. 3 goes into 10 3 times. That's going to be 9. I'm going to subtract 1, 0, etc. Right? It's just going to keep going. So 1/3 is the same as 0.3 with the repeated decimal bar over the 0.3. All right, let's take a look at 3/8. Both 3/8 and 2/5 terminate. All right, 2/5 terminates very, very quickly. Let's take a look at 3/8, which is a little bit more of a challenge. 3/8 would be the same as 3 divided by, can't get the division symbol here. There we go. Divided by 8. My board wasn't happy with me. All right, so what are we going to do? We're going to write that as 8 going into 3.0, maybe add a few zeros on there right away. Again, 8 goes into 3 0 times. When we subtract 0 from 3, we get 3. Drop the 0. 8 goes into 30 3 times. That's going to give me 24. Subtract, and I'm going to get 6. Drop another 0 down, 60. Then we'll have 7. 7 times 8 is 56. Subtract, 60 minus 56 is 4. Bring down another 0. 8 goes into 45 times. 5 times 8 is 40. Subtract, remainder of 0. So 3/8 is the same as 0.375. 3/8 and 0.375 are the same decimal. Trying desperately to circle it, can't get it circled. That's okay. Just a dead part of the board, apparently. Let's do the last one, 2/5, right? Just like before, 2/5 is going to be 2 divided by 5. All right, so we'll have 5 going into 2.0. And watch how fast this terminates, right? 5 goes into 2 0 times. So 2 minus 0 is 0. And then 5 goes into 24 times. Subtract, and 0. That's it. So 2/5 is the same as 0.4. 2/5 is the same as 0.4. By the way, that makes all the sense in the world if you think about it, right? Just for a moment. 2/5, right, is equivalent if I multiply the top and bottom by 4/10, right? If I just multiply the top of the fraction by 2 and the bottom of the fraction by 2, I get the fraction 4/10. But that is by definition what this is, right? That is the decimal form of 4/10, 0.4. All right. So division of two whole numbers that results in decimals is actually pretty easy because it works just like long division. We simply have to keep track of where that decimal point is. The other thing that's a little tricky is, of course, unlike normal long division, in these cases, you can get these repeated decimals, which is a bit strange. All right, let's wrap it up. We're going to be spending a lot of time in the next few lessons on dividing numbers that end up having decimals in them. All right. Sometimes we're going to even be dividing two decimals by each other. And that's going to get a little ugly. But it's all going to go back to what we did today and our ability to divide two whole numbers that then result in a division, that result in a decimal in their answers. So make sure to work hard on your homework tonight. Even though it can be a little frustrating, division that is, keep at it and you'll get better at it, as with everything in math. For now, I'd like to thank you for joining me for another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.